Today we're talking about the properties of acids and bases so we can predict how they'll be able to behave. Our success criteria is being able to identify those properties as well as being able to distinguish between strong and weak acids and bases. So acids have some properties that we know quite well already. We know that they taste sour. We know that they will turn blue litmus red. We know that empirically they have a pH under 7 and a pH over 7. They'll neutralize bases. They can react with active metals to form hydrogen gas. So these would be things like magnesium and calcium, but also chemicals like iron. And they will also react with carbonates in order to form carbon dioxide. Bases, on the other hand, taste bitter and feel slippery. And it's actually because bases will dissolve the first layer of your skin that they feel slippery. Don't do it at home. They'll turn red litmus blue. They have a pH greater than 7 and a pOH less than 7, and they'll neutralize acids. What do we mean in terms of neutralization? Well, in Chemistry 20, we define neutralization as a reaction between hydronium and hydroxide ions to produce water and an ionic salt. That definition will change a little bit next year in grade 12, but for now we can stick with that. It's the reaction between hydronium and hydroxide. And this is going to result in a solution that has a pH closer to 7. It depends where that ends up, what types of acids and bases you add together. If you add a strong acid and a strong base together, it will have a pH of 7 as long as the concentrations and volumes are the same. But the same concentration and same volume of a less strong combination, say carbonic acid and sodium hydroxide, where the carbonic acid is in fact a weak acid, that will produce a different pH. The pH will actually end up on the basic side. Okay, so what are these strong and weak acids and bases? A strong acid has nothing to do with its concentration. It has to do with how readily it reacts with water to form hydronium ions. Strong acids react more than 99%. We say they react quantitatively. They, for all practical purposes, react entirely with water. So the concentration of hydrochloric acid, a strong acid, will also be equal to its hydronium ion concentration. There are 6 strong acids we need to know in high school: Hydroiodic acid, hydrochloric acid, perchloric acid, sulphuric acid, nitric acid, and hydrobromic acid. A high concentration of hydronium ions also means it has strong acidic properties. So we know that acids, because they create ions, conduct electricity. Strong acids will be highly conductive. They will react with metals quickly. They will have lower pHs. What about weak acids? Well, weak acids react with water incompletely, and they form relatively few hydronium ions. For our purposes, we can say that anything that's not one of those 6 strong acids is a weak acid. That's not entirely true. There are other acids that act strongly, but we also don't measure them the same way as we measure these acids. Like superacids, you tend not to measure with a pH scale. You have to use something called pK instead. The lower concentration of hydronium ions from weak acids means they have weaker acidic properties, so they have less conductivity. Their pHs are closer to 7. They'll have a slower rate of reaction. Same sort of thing is true for bases as well. Strong bases are highly electrically conductive and they have a high pH. That's because they contain hydroxide ions directly. So when they dissolve in water, they just break the ions apart. But weak bases instead have to react to produce hydroxide ions. These are things like your bicarbonate ion, your ammonia, Things that don't look like bases at first glance, but if you test them, they do in fact have a basic pH. They react with water to create hydroxide ions, but they do so incompletely, in an equilibrium. This means they'll have lower electrical conductivity and their pHs will be closer to 7.